Greetings and welcome, friends. So, you might have watched my previous video about finding the distance from a point to a line like a caveman would. But we're gonna be a little bit more sophisticated today. We're gonna talk about using normal form to find the distance from a point to a line instead of just plain old algebra. So the following formula can be used to find the distance from a point at x1, y1 to a line with equation ax plus by plus c equals 0. Standard form. So notice this formula, it says d is equal to ax1 plus by1 plus c all over plus or minus the square root of a squared plus b squared. Now this should look kind of familiar to what we did yesterday when we converted from standard form to normal form, right? Yes, you would say. Right? It even has the same thing. It says the sign of the radical is chosen as the opposite sign of c. Man, that's awesome stuff. So it turns out all this is doing is first it's converting this into normal form, and then it's plugging our points in for x and y. In fact, I wrote the or here, where if you actually had normal form for your equation, all you have to do is plug in your point, and it will automatically calculate the distance that that point is from your line. Good stuff, good stuff. So let's do an example of using this, and you'll probably agree it's much easier than the way the cavemen used to do it. So you don't need to summarize all these directions quite so fancy, but let's say I want to find the distance between point 45 and the line with the equation 8x plus 5y equals 20. All right. So first of all, to write that in our standard form, 8x plus 5y minus 20 is equal to 0, right? So you could perhaps gather that the value of a is 8, the value of b is 5, the value of c is negative. I don't even care about you, 20. Don't even care. Well, actually, no, I lied. I do care about you, 20. I just don't care about you when it comes to square roots. But also, it's negative. Bam. I'll write neg down here, sorry. So let's just set this up. The distance, therefore, according to our little formula, is going to equal 8 times x1, which is 4, plus b times y1, which is 5, and then the minus 20, or plus c, right, which is negative 20 in this case, I suppose, all over. Now, is my square root in the denominator positive or negative?
Positive.
Positive, because it's the opposite of the c. And let's see, so it's positive, and I'll have a squared, which is 8, plus b squared, which is 5. Now all I have to do is kind of simplify this, more or less. And I'll get d is equal to, what's that, 32 plus 25 minus 20, all over the square root of, what's that, 64 plus 25, if I'm not mistaken. And 32, well, let's see, 25 minus 25, 32 plus 5 is 37, over the square root of 89. And then, yeah, I could multiply that top and bottom. So 37 square roots of 89 over 89. I don't even know if there's a common value between those. But that would be the distance. If I wanted to find a decimal approximation, which probably would be appreciated if you're doing anything other than math, d would approximately be 3.9220. So I think you probably agree this is much quicker than our previous method, right? Which took a page and a half. This page, this took like half a page, maybe, right? So not bad, not bad. So let me up the ante just slightly, ever so slightly, with one last example. And I'll paste this in here, and here we are. So now, instead of finding the distance from a point to a line, I'm finding the distance between two lines. Which actually, these lines happen to be parallel because asking about the distance between non-parallel lines would be 0 at some of its points, specifically being one of them. But if I want to find the distance between these two lines, all I have to do is pick a point on one of them. Notice the second line is in slope-intercept form. So what's the y-intercept of this line? 0, 4 would be the y-intercept. So I could actually use that as one of my x1, y1s. And then I'll just use standard form for this guy. So that's 6x minus 2y minus 7 equals 0, right? So my distance is just going to be, what, 6 times 0 plus negative 2 times y1, which is 4, plus c, which is negative 7, all over, let's see, is it positive or negative square root down here? Positive, because it's the opposite of the c. And that is 6 squared plus a negative 2 all squared, right there. So the distance is equal to, let's see, 6 times 0 is 0, negative 2 times 4 is negative 8 plus a negative 7 all over the square root. Yeah, wait a minute. Wait a minute. I'm going to end up making the positive of this, but I don't know why my negatives ended up quite that way. So this will simplify either way to d equals negative 15 over the square root of 40, right, which is equal to negative 15 square root of 40. Oh, wait. Square root of 40, guys, I could break that up. Square root of 4 and root 10, we know that. So negative 15 over 2 roots of 10. So I'd multiply top and bottom by root 10, root 10. I think you'd agree. And I'll get negative 15 square roots of 10 over 2 times 10 is 20. And then 15 and 20 cross cancel partially, right? And that's going to be negative 5 goes into 15 thrice, and 5 goes into 20 4 times. Now, as far as a distance, though, we'll just take the positive version of that. And if we do that, 3 times the square root of 10, and then divide that by 4, I end up with 2.3717. Distance. So that's the distance between two parallel lines without too much work, right? I think you guys agree. And what was even cooler was if they happen to be in normal form, all I would have had to do was just plug the point right in. That would have given me the distance. Thanks for watching, Internet friends. Bless you. Bye-bye.